Hi, my name is Aravind. I'm the Director of Strategy for Space at Tomorrow.io. In this session, we're going to be talking about space for climate and the role of Earth observation satellites in climate change. So you probably have heard of satellites and climate change already. Especially, you've probably seen pictures of Antarctic ice caps, Arctic ice caps, or you probably have seen emission data associated with satellites, but there's more to that, right? So there's a lot of companies that are working on climate solutions today, launching satellites. So in this session, what we're going to do is to look at why we're launching satellites in the first place, and look at the type of companies that exist, especially Earth observation companies that launch satellites and work on climate solutions. And then finally, also look at a framework for how to look at these companies and understand this market better. So let's start with why we're monitoring the Earth from space, right? Like, why are we launching satellites, correct? So there are three major reasons for us doing this. The first one is science. So science, this is basically the fundamentals of understanding climate change, right? So we know climate change is happening because we've been launching satellites for decades now. And we know from, data, you see on the slide, two types of data, right? Like the ice sheets melting from Antarctica, but also the land temperature and the rise in land temperature around the world. So this is mostly due to data collected by satellites. So on the left, for ice sheets, we've been tracking them over decades, especially with satellites, and tracking, the development, the growth of them, the decay of them, the melting of ice caps, but also the temperature, tracking how temperature is rising around the world, right? So satellite data is critical for understanding both these variables, and these variables are part of, understanding how climate change is happening around the world. So how do we know that this is happening? As I mentioned, we've been launching satellites. So on this slide, you see, an infographic with the list or a type of satellites that NASA has launched over the years, and this just shows, what we've been doing in space with respect to climate change, right? So this is just, a set of satellites from NASA that are called Earth observation satellites that have been launched over years, and we've been collecting data from all of these satellites that has been super helpful in understanding climate change. And it's the same thing with ESA. ESA is the European Space Agency, and ESA has been launching, satellites as well over the years. And through these satellites and satellites launched from Japan, from India, from China, from Canada, we've been tracking climate change from satellites launched from a number of countries, right? So satellites are very, very important for tracking climate change. So we know that, right? So how do we then understand what satellites are doing? For example, we've understood that, we need to categorize what we're monitoring from satellites into different variables. And what you see on the screen is a group of about 54 variables that has been put together by the Global Climate Observing System, which is a consortium of organizations and research institutes from around the world. So as you see on the screen, this is a set of 54 variables grouped into different segments, right? So each of these segments are very, very important. So if you look at atmosphere, looking at, the temperature in the atmosphere, precipitation, and, on the land, how much precipitation is being collected, and greenhouse gases, for instance, this is something that we've always heard of. All of these fit into the climate variable definition, right? So that's basically, giving us one way to understand what satellites are doing. It's essentially helping us monitor most of these climate variables. And it's been found that for more than half of these variables, it can only be tracked from space. So satellites are very important for doing that. And the second reason is regulation. So you might be wondering what satellites have to do with law and policy, right? So there is. So you take the Paris Agreement, for instance. Paris Agreement, as you know, is an international agreement signed by most of the countries around the world looking at climate policy, mitigation and adaptation, etc. And you look at how do we implement the Paris Agreement, right? Like how are we tracking Paris Agreement? And there was COP26 last year, and there's going to be COP27, and there were a lot of things agreed, right? So how are we going to track each of these over the years and in the future? Again, satellites are going to play a very important role. Emissions you may have heard of, and emissions are a very important part of all the agreements that I've signed related to climate in the past. So satellites, again, are very, very important for tracking emissions. And today we have some satellites, and there are going to be some satellites launched. We're going to look at some companies in the next few slides of what these companies are doing and how they're going to make tracking emissions better. So Paris Agreement, the only way to track how countries are doing on a global level, because satellites are the global truth, right? So satellites can give us data about how we're doing with respect to implementing these agreements, which could become law in some countries, and it's already started becoming law, right? So Paris Agreement is just one example. So look at climate risks, right? Like this is an area that has been getting a lot of attention recently, and you probably have heard or seen the news of the SEC proposing a new framework for disclosing climate-related risks to investors. Companies starting to do that, which is essentially SEC is asking companies to start reporting their emissions, and useful for investors to identify what each company or organization around the world, at least in this case the US, is doing with respect to not only reporting their emissions, but also what they're doing with respect to tracking their climate-related risks. And the same thing is the case with TCFD, which is the Task Force for Climate-Related Financial Disclosures. So you have companies that started reporting it. This is a voluntary framework, but kind of gives you an idea of where the industry is going and how each company, almost every company in the world, will get to a point of starting to report not only their emissions but also their risks of what they have to do in the era of climate change. So policy and regulation, as you might have seen, is a very, very important factor in the future, and it's going to become more and more important. Especially the role of satellites, it's going to become more and more important. Business. So obviously satellites are being launched to do business today, but to add some context to it, you look at this slide. You probably have seen this slide in a session before, but it shows really the amount of damage that is being done by climate change around the world. And you see on the graph, it started reaching hundreds of billion dollars, especially in 2020, it was about $210 billion. So what satellites can allow us to do is essentially, build tools to manage these risks, right? So climate change is happening, billions of dollars are, being wasted today because of climate change. And satellites can help us collect data that can help us address these challenges in the next few years and the upcoming decades. So satellites are very, very important for doing business. And this session, we're going to focus on, what companies are doing with respect to doing business and how we can understand them. So let's look at the Earth observation market for climate, right? So before going into the Earth observation market for climate, let's look at the Earth observation market. So on this slide, you see, a stack of the Earth observation market, an operating stack, if you will. You start with data from the bottom and going up to the applications on the top. So data is basically the companies that are working on collecting data by launching different types of satellites. So we'll get to the types of satellites in the next slide. But to start with, that's the foundation, right? You need to collect data to understand, what we can do for climate change, whether it's taking pictures or collecting weather data. There are a lot of things that we can do and a lot of industries that we're going to serve. So we'll look into that in a bit. But essentially, data is the starting point. And then there are platforms that distribute the data, maybe provide this data in a usable form to companies around the world. So those are the infrastructure and the platform layer. That's what their role is in the market. And then you get about, which is the analytics layer. Analytics is basically transforming all of these data that was collected from the satellites, maybe combining it with other types of data and then making it into an information that can be used by companies, because maybe some companies don't have the capacity to buy the data or process the data, so they want to go buy analytics directly. So that's one layer, as we see in the market. And then there is another layer about, which is the insights layer. So the insights layer is about not only collecting the data, processing the data, but then transforming it into insights that companies can just make use of, especially climate related. And then finally, the application layer, right? So forgetting everything that we said before, there are probably companies today that are building applications that companies are using today that already use satellite data, right? Maybe you haven't thought about it. Maybe it's not part of the space industry. So that's basically the application layer, if we were to look at the market. So this is an overview of the Earth observation market today, right? So this is how the Earth observation market is organized. And I mentioned we'll get to the data part in a bit. The next slide is about showing an overview of all the companies out there that are launching satellites to collect data. So in this slide, you see different types of companies with different type of sensors. So starting from the left, you have companies that are launching infrared sensors. So infrared data is very, very useful for tracking wildfires. Again, it's going to only get worse as it's been predicted over the years with respect to wildfires. So satellites are going to be very useful for that. Satellites are also useful for tracking, soil moisture and what's going to happen to water on the fields, right? It's very useful for agriculture. Infrared satellites are very useful again. And if you look at hyperspectral, so we looked at emissions before. So a lot of these emission satellites are going to have hyperspectral sensor in them. Not going into details of the technology, but hyperspectral sensors allow you to, see the world in a dimension that you cannot see with just a picture. So hyperspectral is not only telling that it's a plant, but also identifying what is the plant, right? What is the species of that plant, or what is the type of material that was used to build this factory, things like that. So that's hyperspectral. And then there is optical, which is the standard sensor. So every picture that you've seen of the planet, whether it's a very high resolution picture or pretty low resolution, all of these are optical sensors, and some companies are again working on sending optical sensor satellites. And on the right, you have radar. So radar is a sensor that sends signal and gets the reflection back. So that's the difference between an optical and a radar, but not going to go into the technology. But then radar is very, very useful because radar is not limited by sunlight. Radar satellites can work day and night. They can work if it's cloudy. An optical satellite, if it takes a picture, it's not going to work if it's cloudy, right? You cannot take a picture of anything because the cloud's going to stop what you're seeing. But radar does not have that problem. You can take a picture not only of the Earth, of the land, but also of the atmosphere, right? So if you are tracking clouds for identifying or predicting rainfall over the years, you need to look at these clouds. So radars are going to be very useful for that. And Tomorrow.io, we are launching a constellation of satellites made up of radars and infrared sounders. Both of them have a different purpose, but if you wait for the next couple of sessions, you're probably going to understand more about what radars are, what are these applications, and what we're building at Tomorrow.io. So I hope you check them out. The sessions with Jim Carswell and Marshall Shepard is moderating a panel with Ricky Roy and Joe Munchak. So I hope you have the time to check that out. But moving back to what we were discussing, there's another category of sensors called radio, right? So they track the radio signals coming out of the Earth. So that's another category of sensors. So as you see, there are lots of types of satellites. So it's probably going to take a whole different session if you were to look at each of these sensors and what they're doing, especially the technology and the use cases. But hopefully that gave you an idea of what are the types of satellites that are being launched today, and gets you an understanding of what the applications of each of these are, because truly they are enormous in terms of applications. But moving on to what our conversation today is about, climate. So Earth observation, as you might imagine, is playing a very, very important role for climate change. And let's look at two lenses. And these are lenses that you probably have heard of before: mitigation, adaptation. So climate change mitigation is about working on solutions and technologies that would help us move away from a global warming future, help us get to net zero, help us stay within 1.5 degrees, like was mentioned in the Paris Agreement. So those are all mitigation relation solutions. And on the other hand, you have adaptation, which is all about building tools and technologies to help us adapt to the changing climate, whether it's predicting climate risk or looking at weather forecasts around the world for everyone, for everybody, or you're looking at doing better insurance models because the IPCC report says that the weather-related disasters are only going to get worse, increase in frequency and intensity over the next decade, especially if you don't do anything, right? So adaptation solutions are very, very important, right? And same goes with mitigation. So if you're looking at tracking renewables, looking at tracking solar power and the efficiency of solar energy over an area, satellites play a very important role there. Or you're looking at carbon offsets and carbon credits, looking at where to plant trees, what type of trees to plant. Again, satellites play a very, very important role there. And also in agriculture, right? Like the carbon sinks you might have heard of, and it's a very important part of the carbon cycle. So tracking that is also possible through satellites, especially on a global scale, on a large scale. Satellites play a very, very important role there. So as you see, satellites have a very, very important role to play across industries, across sectors. But to deep dive on one area, which is adaptation, which is something, at least personally myself, I feel like it doesn't get a lot of attention. Of course, we talk a lot about emissions, we talk a lot about carbon offsets and renewables, but as much as mitigation, I think it's very, very important that we also look at tools for adaptation, because climate change is happening and we need to be looking at solutions that can help us adapt to the changing climate today, in the immediate future. So what I want to do in the final part of the presentation is look at a framework to understand how to look at different type of solutions for climate adaptation, especially using satellite data, right? So it's important to look at adaptation in kind of two segments. And the first segment, I want to focus on responsiveness versus preparedness. So as the name suggests, preparedness is about what we can do to prepare for climate change. It can be installing tools or getting weather alerts. All of that falls into the preparedness category. And then the responsiveness, which is all about an event has happened, whatever we can do to predict the event is going to happen. And in some cases, or in most cases, there's going to be some type of damage. So, we need to respond to an event that just happened. So that's responsiveness. So if you look at climate adaptation, you can look at these two kind of categories. So that's the first segment. And the second slide is about, looking at timeframes. Are we looking at preparing for the long term or preparing for the short term? Is it going to happen? Are we preparing for something that's happening tomorrow, in the next week, or are we preparing for something in the next 10 years, right? So that's an important part as well as we look at adaptation solutions, which is why it's important to look at Earth observation solutions. So what's, data from space is going to help us do across these four kind of quadrants. And let's go through them one by one, right? The first one is about short-term preparedness. And, as you might have guessed, this is kind of where Tomorrow.io we are focused on, and what can we do, what technologies we can build, what tools that we can create to help us, prepare for something that's coming immediately, right? So short-term preparedness, that is the focus for now, at least at Tomorrow.io. So that's kind of a category of companies that work on solutions that's going to help us prepare for an event that is coming in the short term. So that's short-term preparedness. The second category is long-term preparedness. So you may think of an example of buying a house or investing in real estate in an area, but without looking into what the risk of the climate risk or the flood risk of this area, of this location is. It's not important for, next week or next year, but it's very important for the next 5, 10, 15 years. So that's long-term preparedness, building solutions, again, using satellite data, where, they're going to play a key role in not only looking at this location, seeing how that location has changed over years, but also helping, understand weather patterns for an area, right? So all of these fall into the long-term preparedness category. And then, coming down to responsiveness. So, responsiveness, this is something very easy to connect because we have seen that happen in the last few years. So short-term responsiveness is all about how companies build solutions to help respond to, an event that's just happened. So you may have probably seen satellite imagery of, an area that was affected by floods before. So only satellites can do that, right? You cannot send aircrafts or drones, especially if you don't know how the weather is going to change or, the weather is continuing. And we have probably seen events, news of flood events where, this was the case, and satellites help us understand the scale of the damage. And it's very important, not only for governments, but also for insurance companies, for nonprofits, for charities to start, distributing food and supplies, things like that. So satellites, again, play a very important role there. And finally, looking at long-term responsiveness. So what tools can we build to help us automate this, right? Like, we don't have to always respond to something in the short term. We can install tools that can help us, warn of an impending damage. And again, satellites are going to play a very important role because they not only collect data of today, of yesterday, they collect data over a period of time. So you can understand patterns and start to, predict and anticipate these events better. So, this long-term responsiveness kind of goes hand in hand with what we spoke about in preparedness, right? So long-term responsiveness is also a very important component. This is an area that has not been, touched a lot. There's a lot of solutions being built. We are sending a lot of satellites now. We're collecting more data than we've ever collected in the history of humanity about the land, about the oceans, about the atmosphere. So, long-term responsiveness solutions are going to become the norm in the next 5 years, especially if you were to, adapt to the changing climate, depending on wherever you are at that point. So hopefully that gave you an idea of, what the, Earth observation market is doing, how space industry is contributing. This was just a small overview, and hopefully this gave you an idea of how different companies are working on different sorts of solutions, and we need all of them to, help us respond to climate change. And at Tomorrow.io, we're very happy to be working on, our space program and our software to help us, respond to climate change and adapt to what's happening, especially related to weather events. So I hope, you gathered some insights on what's going on with the Earth observation market through this session. And I hope you all enjoy ClimaCon. We have a lot of exciting sessions coming up, so I hope you stick around and enjoy. Thanks very much.
If you missed any of today's sessions, no problem. You can catch all of them at climacon.tomorrow.io on demand anytime you'd like.